Okay, so we had this up here today for Hello Smart, and I wanted to get you ready because these are the three types of questions that'll be there. You're going to have to be able to go from standard form to vertex form. Okay, this first one is about vertex form. All right, so what you do is you find the vertex, which in this case it's the turning point. There's some people I'll show you later who got it a little backwards, but anyways, that's the vertex. And the vertex, the coordinate of the vertex is 15, comma, what is it up here? 5, 10, 25. Okay? So this information is important because in vertex, it is this first number, the x, is the one that goes in the parentheses, but you have to negate it. You have to negate this number. All right? And this one is the number outside the parentheses, and you don't negate this one. This one is actually where it is. So that's two clues. So we're going to use in the parentheses, it's x minus 15 plus 25. Okay, so that's very easy to get, right? The 15 goes in here, it's negated. The 25 goes right out there once you find out what the vertex is. Very simple. Now, a lot of people chose 3. But right from the beginning, we had learned that an upside down parabola, you have to have a negative up here. So q of x has to be a negative number. So they're all 1/2. So negative 1/2. Very important, right? Upside downs are negative. They don't hold the water. Right, right side up are positive. So this one is number 4. Okay, a lot of people gave 3, which you had the negative 15 and the positive 25 right on the vertex, but that would have been a one that went up or held water, not an upside down one. Okay, let's look at the next one. All right, so here we go. So we look at this one, right? And we have um, this equation, and we want to get it into the vertex equation. So you have to use your calculator, right? So I'm going to use the calculator. I'm going to put it in. I'm going to go to y equal, right? I'm going to clear this one. And I'm going to put in x squared plus 14x minus 3. Okay, now I have to find the vertex again. So, I mean, you can graph it and try to find it, right? Then you have to do a second function, a zoom, 0, right? And it's over here, it's a mess. But what you can do is you can go to the table. Okay, now we have some clues, right? We have y is going to be either negative 52, positive 46. You know, we can pick these off. This one has the vertex of negative 14, comma 49. Okay, so we can go there and see if that's where it's symmetrical. This one is negative 7, negative 52. Let me erase that. That's sloppy jalopy. All right, negative 7, negative 52. Right, these are the vertexes. This one's negative 7, positive 46. Okay, so let's get the our calculator back here. So we go to table, and we want to go. We have to go to the negatives. So if we look at -7, put it right in the middle of your screen. Okay, so -7 has -52, which is good, but is it symmetrical? Are they the same on each side? So if you go up one, it's -51. You go down one, it's -51, and then the pattern repeats. They're the same up and down. I like to get my vertex right in the center, and then you can see the top one is -27, and this is -27, and then the next one is -36. So this is where the vertex is on your calculator: -7, -52. So it's 3. Now, I know some of you don't have a graphic calculator. I tried to get you this one. It was a total disaster. Let me see if I make this bigger. Can you see it better? So you see how this is in the middle, right here, this line, and then they're the same on each side. That's symmetric. Okay. Some of you don't have it. So what do? So I said, well, let's get a Desmo in here. Let's do Desmo, right? I'm going to clear these out. You know, I'm a geek. I'm just playing with numbers and stuff. And I'm going to put it in here. Y is equal to, this one you have to put the Y. Y is equal to x squared. Where's my x? Oh, x squared. Sorry. Oh, brain freeze. Plus 14x. Or is that old man brain? Minus 3. Okay? Now, this one's a little bit different, right? We're looking for that symmetrical. You can actually zoom out and find and click on the vertex. What does that vertex says it is? -7 minus 52. I mean, come on, it can't be much easier than that. So I know it's +7 minus 52, right? +7 minus 52, +7 minus 52. Okay? So that's how you go from standard form to vertex form with your calculator. All right. Now this one down here was funny because I wish I could move this guy out of the way. This is that's the recording button. So here we go. So this one I asked you to make a table and then plot the points, right? And then state what the vertex is. So again, you take out your trusty little calculator. Now, remember, the vertex, I'm not going to give you one. It has to fall within here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10 by 10 square. So the vertex has to fall somewhere in this 10 by 10 square in each of these quadrants. So it's not going to be some like crazy number. You're going to get points to plot within this 10 by 10, -10, +10, -10, +10. All right, so let's put this here. Let's clear this one. Clear. Let's put in this one. This is x squared. This is in standard form, minus 4x. I mean, if you had one in vertex form, you would just put it in the same way. It's the same graph, -1. Okay? Then we go to the graph, right? So you can see it kind of comes in here. I don't really like that. I said to make a table. So what am I going to do? I'm going to go second table. Now I have to find where I get that nice symmetrical. So I know that -12 is no good. So let's go down. I mean, if you wanted to start at 0, you could start at 0, right? And let's see what happens here. If we start looking at these numbers, it's going 11, 4, -1, -4, -5, -4. Oh, wait a second. -4, -5, -4. That sounds like that would be the turning point to -5, right? And then we check. Look, there. So if you wanted to put it right in the middle, now I'd have to go up and get this top number the same as the bottom. Now we have 20, 11, 4, -1, -4, -5, and then we have them on the other side. I'm going to write these down real quick. And you only have to do like, let's say if you do 4, you get total all the points. The one in the middle, which is what? -2, 5, -5, right? No, wait, -2, -5, 0, -1, -1, -4, and -2, 11. Okay, and then on the other side, it does the same thing. So it's -3, -1, right? Oh, I'm sorry, we should go the other way. Uh, -2, negative, let me write them down. So what do I have? -2, -5, 1, -4, 1, -4, 2, -5, all right. And then we graph these points. Let me write them down one more time. I have 0, 2, -5, 1, -4, I'm going to go 2 on each side. 1, -4, 0, -1. I got 3, -4, and 4, -1. Okay, let me see if I can plot those points. All right, so I just use the dot with a bigger, I just make it a little bigger. So I'm going to go 0, -1. That's that point right there. 1, -4. Um, well, discombobulated here. 0, -1 is this one. Let me erase that one. All right, we'll start over. 0, -1. 1, -4. All right, that's that point there. 2, -5. And then it starts going back up. It's this one, it's this one. Okay, so you get the gist of it. So it comes down, goes around, then comes back up. Okay, but you also have to write your table. And you know, your table of values could just be the points. The points were 0, -1. All right, 1, -4. 2, -5. Okay, so now it should start going back up. 3, -4. And then it was also 4, -1. All right, so your table could be like that. You could do X's and Y's, you could do whatever. The vertex is the point where it turns around, goes back up down here. So this part was 2, -5. All right, so those three will be on there. Maybe not be, they may not be a multiple choice, but you have to be able to go standard form to vertex form. That'll be on there. And you'll have to draw a parabola on a coordinate plane and find the vertex. All right, I hope this helps. I'm going to post it and have a wonderful day. The sun's going in and out, birds are chirping. Mrs. Siegel went food shopping, bought a lot of goodies. We're hunkered down for another 2 weeks. Have a great day. Tomorrow, 10:30, everybody's on Hello Smart.